Good afternoon. My work is about, let me check that one. My work is about BIM for information managing structural safety control of embankment dams. This presentation have 5 topics. The first one is general information with some pitfall and opportunities that we identify, and the workflow for this work. In the second one, we present a workflow too, but the computational workflow with some details about the implementation. The third part is application of this workflow in a case of study in existing embankment dams. And finally, the conclusions, the main conclusions. Then have been built to size antiquity for a different kind of uses. And although we have a lot of improvement in technology and structural and geotechnical works, we still have huge problems like that. With dam failure, when we have a rupture of the dam, we have a lot of social environment and economic impacts like that. But the main dam that type, we have a lot of type of dams, but the main one that we have constructed around the road is the embankment dams. And to control the safety of these dams, we use 2 kinds of things like visual inspections and analysis of instrumentation. For the embankment dams, we have a lot of kinds of different kinds of instrumentation to measure different kind of parameters. But just for an example, I put here 3 kinds of instrumentation. The first one is piezometer to measurement the pore pressure inside of an embankment dams. The second one is to identify the displacement, but the superficial displacement. And we have a kind of instrumentation that measurement the displacement inside of the dam, along the depth. So that's it. And we identify for this kind of analysis, the instrumentation data, the instrumentation measurement, 3 kind of pitfalls. The first one, most of the dams still have the manual measurement. This increase a little bit the high time, the time to take the measurement in the field and analyze this measurement by an engineering office. Well, so for this kind of thing, you see that the real-time instrumentation measurements could be improved, this kind of thing. But it's used by IoT with BIM model can improve this kind of thing. The second pitfall is the presence of several files. For each instrument, we have a spreadsheet. So we have a lot of files that not concentrate this information in the same place. So this is a kind of thing that difficult the work. For a solution for this kind of thing, you see that BIM and database could solve this problem. And the final one, that visual inspection in a dam, it's not a constant thing. It's periodically performed. So maybe use a drone with a camera and take this information, put in a database, and use a kind of artificial intelligence could improve this kind of thing. So you see that have a lot of kinds of use of BIM, a database to improve some problems identified in measured data from instrumentation analysis. So in this work, you work in the second pitfall, that try to solve this kind of thing, the presence of several files, and put all this kind of thing in the same place. So because of that, the main goal of this work was for existing dam, take all the information about the instrumentation and put in a same place. For doing that, you propose this workflow that we create a database that concentrates all the information data of the instrumentation in this database, create a kind of automatically interoperability between tools that you have the geometry and a BIM model, and connect the data from the database to the BIM model, the instrumentation data. Also connected the database to another kinds of tools like business intelligence to analyze this data and take this information from the measurement data and connect to the BIM model too. And this is for the existing data. And for the future data is the same thing. Take the data from the field and put that in the database. So that one is another workflow that shows how we implemented that, the computational workflow. We divide it in 4 parts. The first one is take the geometrical information and put that in the BIM model. For that, you use spreadsheet, Dynamo, and Python. The second one was create the database, automatically creation of database, and take all the necessary information from the spreadsheet that exists and put this information in database too. The third part is connection, the instrumentation information to the BIM model through the family that we'll create in the BIM model. For this connection, we use the Dynamo tool. And finally, you connect the information of the database to Power BI. That is a kind of tool for business intelligence to analyze the data, and connect this information to the BIM model, again, using a family to visualize in 3D, in a 3D model, the result of the measurements. So for the first one, the geometric modeling, we have mostly the geometry of a den in AutoCAD. So we take the information of this geometry from the AutoCAD, transforming that in a spreadsheet. You just take the points of external line of each structure. For this work, we work with the embankment and the core of the dam and the drain, just these 3 structures. So we take the external points for each one, transform that in a polygon, create a solid, and by the solid, just for the embankment, then we make the difference between the core and the drain. So we have these 3 extruders. This is important because have the position, the geometry of the embankment, then just to visualize the position of each instrument, if intercept or not the drain, if intercept or not the core, this kind of thing is important to analyze the data. So the second part is the creation of the database and put the information into the database. The creation of the database choose was a relational database, which you have, it will look like you have a lot of tables that have connections, relationship between each table through a parameter. So we have here one table that is general information of them. The second one is information of each instrument, like position of the instrument. The third one is the measurement data of each instrument. And these another ones that have different colors here is the measurement of each kind of instrument. For this work, we just implemented the red one line that represents the instrumentation that measurement the displacement along to the depth of the embankment. So the third part is connection of the database with the BIM model. For that, you create a family like that. This is, but not have not just the geometrical information, have the non-geometrical information, and to plot this information, to plot the position of the instrumentation, the instrument in a BIM model, you take the information from the BIM model, take information from the database, compare if this instrument exists or not in the BIM. If exists, you don't plot. If not exist, this instrument is plotting the BIM model. It is useful because you have a lot of spreadsheets. So to compare if the instrument exists or not is necessary to plot this to make this kind of verification. So this is the procedure you did with Dynamo and some Python code to analyze, to plot this kind of information. So the last one is the visualization of the data. Oops. Okay. The visualization of the data. To visualization the data, you use another kind of tool that connects to the database, and you connect it to the BIM model through another kind of instrument, another kind of object create that the height of this cylinder corresponds to the displacement measurement during the measurement data. And you put some information about the height measurement and the low measure, and create a scale of color just to make a visualization of this displacement along to the depth. I will show some examples. So the case of stud was Odeoluca Dam, is an embankment dam located in Portugal. This is for water supply. And we implemented the free structures. We simplified, of course, just free structures that the embankment dams, the core of them, and the drain. So this is the location of all the instrumentation of the data. And remember, you just use this kind of instrumentation that give us the displacement along to the depth of the dam. This instrumentation is located here in the top of the dam. So to visualize the results that you obtain, you see that all information is concentrated in the BIM model, geometrical, the location, and the data measurement, all the information here. So in the BIM model, you can see the geometry of the dam, like that. The instrumentation, visualization, the geometric data, like the visualization, the position of the instrument. You see here we have 4 positions, and if you have a zoom here, you can see that here. And finally, we have the instrumentation visualization, the measurement visualization. Like I told, we create another object that have the displacement, like the height, and we can see by the color which is the major and the lowest measurement. And you can see in the Power BI too, all the measurements by the data, and connect this kind of analysis between these two tools, BIM and Power BI. So the main conclusions, you could put all the information in the BIM model. Of course, that you need to put all the information of all the instrumentation, not just the instrumentation about the displays along the depth. You have to connect all this kind of information to make all the safety analysis. And but it is possible to concentrate all this information. And another kind of thing that you could do with BIM is connected to another tools like finite element analysis to make a detail of this kind of analysis of safety of the dam. So that's it. Thank you very much.